Alright, time for the solutions for the introduction to sequences and the sequence start assignment. So what you need to do is get the next 4 terms on all these. Well, first figure out the pattern. Each of these is going to be slightly different, but look closely for different clues, like try different things out. See if you can figure out the patterns on this one. I notice that difference is 1, the next one is 2, the next one's 3, the next one's 4. So this one, you're just adding the next higher number. So add 1, add 2, add 3, add 4. And when you add 5, which will give me 16, and when you add 6, you'll get 22. And if you add 7, you'll get 29. And if you add 6 to that, you're going to get 35. And so there's your first one. The next section here, this part I know is the same thing as times by 3. And that's actually the same for that one and that one. And so if we want to get the next one times by 3, it's going to give us 243. And we times that one by 3, we're going to get, hold on one moment, 729. And if you take that and you times by 3, you'll get 2,187. And if you take that and you times by 3, you'll get 6,561. And yeah, just use a calculator to do that for you. You can do all those crazy times by 3 calculations that you want to do. And then on this next problem here, when you're going through these, try and figure out what like the add or multiply part is. Like this could be multiplied by 3, but this next one's not multiplied by 3. This one can be add 2, the next one can be add 4, well add 8, add 16. Also, it's looking like we need to add multiples of 2 to the x power, so adding 2, 4, 8, 16, 32, etc. So you can also think of it as adding one more than what you started with, and if you do that, you're going to get 63. And if you add 64 to that, you're going to get 127. And if you add 128 to that one, you're going to get 255. And if you add 256 to that, you're going to get 511. So that's going to be the next 4 terms for that one. On this one, if you're going to go smaller, you can subtract a certain amount, such as 96. But you won't do the same thing there. You'd be like subtracting. It's way more than 96. Well, another way to deal with it is to divide by 2. And if you want to change the sign on something, you're going to make it negative. And that'll be good, because if you divide by -2 again, you're going to change the sign back to positive. And if you do it again, you're going to change the sign back to negative. So the pattern is divided by -2. So when you do that, you're going to get 12. And when you divide by -2, you'll get -6. And when you divide by -2, you'll get -3. You'll get positive 3, sorry. And when you divide by -2 again, you'll get -3/2. And for the next one, this one is a pattern of adding 4, adding 6, adding 8, adding 10, and so on and so forth. And that'll give you, so you have to add 12 to get your next one, so this will give you 42. And then you need to add 14 to that, which will give you 56. And to that one, you have to add 16, which will give you 72. And if you add 18 to that one, it'll give you 19. So those are going to be our 1 through 5 part. On this next one, these numbers are just doubling on the bottom. So you get 1 over 32, 1 over 64, 1 over 128, and 1 over 256. On this next one, this one might throw you off a little bit, but these numbers are the same thing as 2 squared, 3 squared, 4 squared, 5 squared. So if you want to get the next one, it's 1 over 6 squared, which is 36. The next one's 1 over 7 squared, or 1 over 7 times 7, which is going to be 49. And the next one's 1 over 8 squared, or 1 over 8 times 8, which is 64. The next one's going to be 1 over 9 squared, or 9 times 9, which is 81. And this next sequence here seems like a bunch of random letters. But if you think about the days of the week, you have Sunday, Monday, Tuesday, Wednesday, Thursday, which will make the next one Friday, and then Saturday, and then Sunday, and then Monday. And the pattern starts repeating like that. And if you realize that one, it's pretty quick to get this next one. These letters represent the months of the year. So you got January, February, March, April, May. Well, then you got June, July, August, and September. And those are going to be those next letters there. And then on the pattern for 10 is to add another row on another circle on the top and bottom row. And so when you do that, the next one's going to give you 4 circles up top, 5 circles on bottom. And the next one's going to give you 5 circles on top and 6 circles on bottom. Sorry, I put those really close together. And then so on and so forth. Let me draw those real quick. Alright, there we go. So I got those ones drawn for you. It turns out to be drawing a lot of circles. Well, the pattern on 11 is to add, well, from here to here is to add a box up and a box to the left. And on the next one, oh, it's looking like we need to add a box up and a box to the left. But then we got this extra one here. So it's looking like we're more like adding a diagonal row of boxes. So if we were to take this and add a diagonal row of boxes, we'd, and having that one there, we'd be looking at one that was 4 long here. 1, 2, 4. 4 long this way. And then box, and then adding ourselves some boxes. So we can get that guy there. And then the next one is going to be 5 long, 5 tall, and then again these boxes here. Oh, I think I have too many boxes again. I did this last time. Anyway, let me draw that real quick. There we go. There's that one. Sorry, I drew way too many boxes. I do that every time. So the next one we're going to get 6 and 6 and the diagonal boxness. And the next one we're going to get 7 and 7 and the diagonal box stuff. So let me draw that real quick so you know what it'll look like. Anyway, so there's the end of that drawing. There's a lot of drawing. Anyway, a lot of boxes. Moving on to the back side, this pattern here is just adding 6 each time. So if you want the next one, you get 32, and add 6 to get 38, and then add 6 again to get 44. And you're supposed to say whether it represents a linear or an exponential growth. Well, if you're adding the same thing every time, it's going to be linear. And the next pattern here is timesing by 5, times by 5, times by 5, times by 5. So if you times by 5 again, you get 125 with 2 zeros on the end. If you times by 5 again, you get 625 with 2 zeros on the end. If you times by 5 again, you're going to get 3125 with 2 zeros on the end. And multiplying by the same number every time, it gives you a exponential pattern. On the next one, this one's a little bit weird, but if you look closely at the numbers and mess around and try to figure out what's the difference between them all, you notice that it's all subtract 41, subtract 41, subtract 41. And I'll keep giving you the next term in the sequence. So if you subtract 41, you'll be looking at 547. And if you subtract 41 again, you'll get 506. And if you subtract 41, you'll get 465. And if you subtract the same thing every time, that is a linear pattern. The next one is a process of dividing by 3 every time. And so when you have something at the bottom already and you divide by, say, 3, you're going to take the bottom and times by what you're dividing by. So it's going to be 27, and then 7 over 81, and then 7 over 243. And this is a exponential pattern. Let me circle those parts for you. And the next guy here, this is actually the Fibonacci sequence. If you want to get the next one, you add the last two terms together, which will give you, in this case, 55. And if you want to get the next one, you add the last two terms together to get 89. And if you want to get the next one, you add those together, which is going to give you 144. Hold on one moment. Yeah, it'll give you 144. Alright. And this one is actually going to be neither. It doesn't grow by a constant rate, and you don't multiply by the same thing every time. You don't add the same thing every time, so it's not going to be exponential or linear. But on 6, you have a center dot, and then you're adding a dot each time to each of these legs here. So if you want to get the next one, you put down a solid dot, and you do 3 dots out. And some of these are more dot-like than others. But if you want to get the next one, add a dot to each of those, and so on and so forth. And that's what the next two will look like. And this is adding 4 dots each time, so it's adding the same amount each time, so this one's going to be linear. Moving on to the back page, I'm just going to tell you what the patterns are, and I'll draw the rest to show you what it's talking about. On this first one, you're adding another box to each of the legs, and the height and the leg part. And so if you want to get the next one, add. This one, you're just adding an extra triangle on top. And then these ones you're adding another row of boxes around the edge. So let me draw and show you what that looks like. So anyway, that's what these next pictures should look like. And this here would be linear because you're adding the same amount each time. This here and here would be linear because you're adding the same amount each time. And this last one is going to be neither because, well, it's just weird. You're adding a weird amount of boxes each time. It's not consistent. Or you're not multiplying by the same thing.